Hi, my name's Ian, and in these videos we're looking at the new features in Scheme for Macs version 0.2. And in this video we're going to take a look at the new dictionary input and output facilities. Okay, we have here a Macs patch with a named dictionary. It's called D1, and I created it by importing from JSON because that's the easiest way to make some nested dictionaries. So if I double click it, you'll see the file I used to get the JSON into the dictionary. We have a mixture of simple values, array values, and nested dictionary values. And now I'm going to clear this console, load up the file with our dictionary examples, and we'll step through them. So first, let's see if the console is listening properly. Okay, there we go. I'm going to turn off log nulls. And let's start by reading a value from a dictionary. So dict ref, the name of the dictionary, and the key. And in this case, the key is a string value. It's the string A. In Macs, that's a symbol. So if we used just the value A without any quotation marks to set it, this is what Macs would show us in a JSON view. In Scheme, we don't need to use string quotes. We can use single quotes for the symbol A. So I'm going to ask dictionary D1 for value at A. And there we get it, value 1. Now let's ask for value at key B, which is a nested dictionary. So if I do that, dict ref D1 key B, you'll see we get a hash table in Scheme. So generally speaking, dictionaries convert to hash tables, arrays convert to vectors. And this syntax here is the readout for a hash table. It's also similar to how you make one, and it simply goes key value, separated by spaces. Okay. Now, let's get a value from the hash table that we just got returned in one function. So what's going on here is dict ref d1b will get us that nested hash table, and the function hash table ref symbol ba will look up the value at ba in this nested hash table. Oh, our listener's gone to sleep again. There we go. 2. Now we can also use the short form version of that S7 Scheme supports, which is also called applicative syntax. And that means that if you put a hash table in the function spot of an S expression and send it an argument for a key, that is treated as hash table ref. So here we go. And then we get value 2. Okay, let's go and get a vector from the dictionary. And at the same time, I'm also going to introduce keywords as keys in dictionary. And this is what I would recommend you use in Scheme for Macs and Macs. It's the norm in Lisps that support keywords. A keyword is a symbol that always evaluates to itself and starts with a colon. So that means that we never need to worry about whether we should quote it or not. It's always going to evaluate to the symbol. And this works very well because Macs just treats them as strings. So on our Scheme code, we can use keywords. Over on Macs, they'll happily get converted from strings. We don't need to worry about anything. Let's try that out. I'm going to look up in dict D1 the key at keyword C. And there we go. We get back the vector 111 or 112233. We can also use applicative syntax on vectors, so we can look up the value at index 1 in that vector. And there we get 22. Okay, let's get a compound value from the dictionary. Dictionary lookup will recurse down any nested dictionaries and arrays. So I'm going to ask for the value at the keyword D. And over here we can see that that is a nested dictionary of quite some depth. It's got the key DA with another nested dictionary with a vector, the key DB with a vector, and the key DC with a vector, and some nested dictionaries. And you can see in our REPL, we get nested hash tables and vectors. So it works out really well. Setting a value is pretty straightforward, much as you would expect. We can set the value, and let's go look at whether that worked by sending the get message here. And we can see key A is now 99. This JSON window does not update because this is simply the Vim buffer that was used to make the JSON file. Okay, let's get a value with recursive list lookup. And this is similar to the max functionality where you can send a dictionary key with double colons to say that you want to recurse through a set of keys. In this case, we're going to ask dictionary D1 for what is at the value of 2 in DAA, in DA, in D. And there we go. We get 99. We can also set, well, let's look at what happens if we ask for a bad key list. We get an error. So we get a key error in Scheme. And catching errors in Scheme is pretty straightforward. It's much like other dynamic languages. I will make a tutorial about how to do that as well later. And that makes it fairly straightforward for us to make a Scheme function that handles a bad key any way we want. So we can have it return a default value or return null. I opted for having it throw an error on a bad key because it is easier to make fallbacks out of errors than the other way around. Okay, let's set using a recursive list. So we're going to set the value at D, DC, 2, and E to 111. Okay, and now if we ask to get it back, oh, our listener's gone to sleep again. Oh, there we go. We are getting 111 back. Finally, there is the dictionary function dict replace, and this is the version of the dict replace message that you can send to the dict object in Max. And the difference between that and dict set is that if we send it a list of keys and traversal doesn't work because one of these keys does not have an entry yet, dict replace will go and make the intermediate dictionaries for us. So to give you an example, we have no key named foo. So if I ask to set the value at the key bar in the nested dictionary at the key foo, it would be an error with dict set. But with dict replace, that's going to succeed. And now we can ask for it back. And we will see that D1 key foo now holds a hash table with a key bar and the value 999. So that gives you a fair amount to work with for dictionaries. I do plan to add some additional helper values such as creating dictionaries that don't exist, checking for dictionaries, asking for the list of keys, and so on. But at the moment, you ought to be able to implement anything you need to do with dictionaries with the functionality provided. And this is very useful because it gives us an easy way to save state. If we save the state in our Scheme programs in dictionaries that are shared with Max, we can save those dictionaries and load them up in Max from files. We can also share them easily with Node for Max, which gives us the opportunity to interact with our file system. And that's a pattern I use regularly. Node for Max is excellent for leveraging all the Node libraries for interacting with the rest of your system or the broader world, getting things from the network. And Node for Max mostly treats dictionaries as the serialization method of choice. So being able to use dictionaries natively in Scheme for Max means that we can make systems where our domain model is in Scheme, our state is stored in dictionaries, and we use Node for Max for loading and saving files and dealing with the rest of the world. Okay, I hope that was helpful, and in the next video we'll be looking at the new transport controls.